Okay, right. So just a couple of words about Jasmax. Jasmax is the sponsors for tonight's event. We provided food and drinks, not that there was enough for a whole lot of you, but so Jasmax is one of Australia's leading architectural practices, aiming to produce work that is mutually beneficial to both society and environment. For almost 60 years, Jasmax has been at the forefront of bicultural and sustainable design in the Pacific. The multi-award winning practice works across a wide range of sectors, including education, residential, culture, and community, commercial, health, sports and recreation, transport, and master planning. Jasmax offers multidisciplinary expertise and integrated design solutions across architecture, interior design, urban design, landscape architecture, and brand design. With studios in Tamaki Makaurau, Auckland, Te Whanganui, Atara, Wellington, Otautai, Christchurch, and now Sydney, Jasmax works collaboratively and creatively to combine practical needs with innovative thinking to provide design solutions that exceed expectations and reach and connect communities. Also, thank you to Warren and Mahoney for being the venue sponsor both here and in Wellington. That said, here's the list of speakers. So we got 6 amazing people that decided to put their hand up today and share some of their experiences with regards to AI. And before the first 2 speakers start, the first 2 speakers are from Jasmax, but before we start, I just want to hand over the mic to Melanie Tristram, who's the digital delivery lead at Jasmax. It's good to say a couple of words.
Thanks, Monica, and thanks to the Digital User Group Committee for organising tonight's event. It's definitely an exciting topic, and I'm not wanting to poo-poo on the parade of everybody about AI. But at Jasmax, we are developing our policy currently around how we are using AI. For us, it's really critical that we are looking after and protecting our company, our client, and our project and our employees' data. So presently, we are not using AI on any production work. We are awaiting our policy to be approved by our board, which should hopefully happen in the next 2 weeks. But the work that Michael and C are presenting tonight are part of our research works that have helped to identify and develop that policy. So yeah, I want to hand over to Mike now to carry on with the presentations.
Right, I don't know if it's good to be up first or last, but here we go. So I'm going to be speaking very much from the perspective of a kind of a novice. I am in the process of learning Dynamo, learning C#, and just having a bit of a dabble with ChatGPT, which I use a few times a week. And I'm sure everyone by now is aware of ChatGPT and what it's all about. So today I'll just briefly talk about how I've been using ChatGPT for quickly solving logic and maths problems. And I'll just show this using a recent example. I had a recent request to assist on a project to develop a method of exploring frit designs for the glass of north and west facades of a building where it gets all the solar loading. There'd been no external shading for the facades, so a frit pattern to the glazed facades was used to reduce the solar heat load. And just to make it interesting, the north, let's see if I can switch onto this first slide. Sorry, there we go. So that's what we're talking about. So just to make it interesting, the north facade of the building was comprised of pleated panels. The initial brief from the engineers called for a 27% frit coverage of the north facade and 37% coverage of the west. But the brief was to be able to explore multiple different percentages of coverage and frit designs. The pleated north facade comprised a series of short and long panels, and aesthetically the frit was to be confined to the shorter of these panels. So I began by simply calculating the total coverage area by the required percentage of the frit, and then knowing the panel width, I also had the clear unfritted area of the panel as well. So to begin with, I was to present the designs for 27%, 20%, and 10% coverage options for the north facade, and 37%, 20%, and 10% coverage options for the west, just to explore the different options and to see if we could achieve what we needed to with lesser coverage of the frit. It was decided that the frit patterns to explore would be vertical strips, and either strips of uniform width equally spaced or strips equally spaced but with successive strips decreasing in width along the series. This first option of the uniform strip widths and equally spaced was quickly discarded because it started looking like bars on a prison window. So I needed a maths formula that, given the width of the first frit strip and the number of strips, would provide the widths of each of these successive strips, and the total coverage of the strips would be the required percentage coverage for the design option being explored. Now, this kind of maths is not my strong point, so this is where I turn to ChatGPT. In the prompt, I just entered a detailed description of what I was trying to achieve. And what continues to surprise me about ChatGPT is that it doesn't just spit out a formula, but explains the logic too. So it can be used for learning new skills. It also let me know that it needed additional information to perform the calculation for me. So after I entered the required data in the next prompt in the chat, ChatGPT walked me through the calculations. After this, I could take the information I had from ChatGPT and start using Excel to build the data that I needed to represent the frit patterns. I used the Dynamo script to read the Excel data for the strip widths, the gaps between the strips, and the position of each strip from the edge of the panel to represent the pattern in a Revit model element. And this was used to explore each of the options. So it's not really that easy to see in this slide, but these are the initial designs of the north facade panels using the uniform and decreasing strip widths for the first 3% coverage options. So I was then asked to explore the option for the west facade of using a frit dot pattern on 3 sides, with the solid frit at the edge of the panel and fading away as the frit progressed inward from the panel edge, using decreasing frit dot sizes. I don't know if you can see that on the right-hand side. So once again, I turned to my trusty assistant to help me with the maths. And this option was discarded too, and it was decided to continue exploring just the vertical strip options. This slide just shows the development and exploration of each of the various options. Each of the columns of thumbnails on the left-hand side shows the options for a specific percentage of coverage. I simply used a new Excel worksheet for each of these options, so I could easily revisit the data for any that I'd done previously. Once the Excel sheet and the Dynamo script had been created, a new option could be explored in as little as 5 minutes. And then on the right-hand side, I'm just showing the final 2 options that were chosen. And finally, this slide shows a couple of the renders of the selected pattern and the physical mockup. So I just wanted to present this and just share that my learning has been that ChatGPT can be used for quite small tasks, and it can still make a big difference in saving your time and improving productivity. And then just to end off, I also used ChatGPT with developing the Dynamo graph. But the free version of ChatGPT, I think the data set ends in 2021. So some of the recommendations that you get are not really valid. One of the prompts suggested that I use the Lunchbox package, and that was discontinued, and it's only now supported for Grasshopper. So it can be good, but it has got its limitations. But yeah, I hope that was interesting.
Thank you so much, Mike. We just thought we would leave all of the questions for after all of the presenters have gone through the presentations. So with that, Xi, would you like to?
Thank you, Michael. That was very inspiring. So hi, everyone. My name is Si Shao. I'm an architectural graduate from Jasmax. So today I will be sharing my experience with virus. As you've already know, Jasmax is still going through finalizing our AI policy. So today I will be just talking about and pretty much summary a YouTube video by the River Kit. So that's the information. So you can look it up on YouTube. Right. So basically, this tool is for Rivet, SketchUp, and Rhino. So what you need to do here is that you just need to bring up a 3D view from, so this example pretty much is just for Rivet. So you just need to open up a 3D view and with the correct perspective and angle setup, and then you just launch Varus. And then for the Revit tool, so it's pretty small here, but I can show you a bigger photo later. So basically you just launch a Varus window, then you can generate a new image. So this is basically the basic workflow for this tool. And so here I will be talking about this example particularly. So for Varus, you have some sliders on the side. So if I can move my mouse, I'll use the pad here. All right, cool. So the first slide is called creativity strengths. So basically, the bigger the number is, the crazier this tool will generate the image. And the second one is style strengths. So it's just basically responding to the style prompt you gave to it. And the width is just changing the width of the photo. And also the last one is the number of rendering. That's pretty self-explanatory. And then we still have a few more. So this one is, the first one is basically a toggle, just to tell Varus if this one is an interior render or not. And then another one is turbo nature. So we'll just give an extra punch on the vegetation of the render. And then atmospheric, just to give it more gloomy feel. And then is aerial view, so just to tell Varus the exact perspective of this render gonna be. So here is a quick example. We have this prompt here. So it's very straightforward. So basically this is the result you get from Varus. And then if we go to the next page, so what I want to share this one is that you can use Rivet to actually guide Varus to generate a more kind of customized render. So for example, this one, we have the Rivet environment in here. So it's a very simple meshing, just two boxes putting together. And as you can see, for this prompt, you just getting a very confusing result where the glass goes all the way to the roof and wrapping around. So probably this is not ideal. So what you need to do is that you actually assign a different material in Rivet. The Varus is able to pick up the material difference. And then with the same prompt, it can actually give you a more ideal result. And the next one is one of the best practices of using Varus is that by using parentheses to give highlights. And so this is the first render. Basically, you're just telling the tool to generate an interior shot, but without any emphasis on any particular prompts. And the second photo is we put green furniture in parentheses, and then you can see it immediately changed the furniture color from a white furniture to green. And then we're just adding to that prompt and adding dark wooden cabinets. And then we'll just change everything, all the cabinets into dark wood color. Right. It's going backwards. Right. So basically, forward. Yep. So basically, there are 3 general tips from this video. One is direct the AI with materials and model elements. So it can pick up all the model elements from your CAD software. And also, so the more prompts you use actually is a better way of telling the tool, because it can take as many as prompts you give it to it. So it will have more information to process. And the third one is just to put your emphasis in parentheses so that it will just highlight or focus on one area rather than the other areas. Cool, and that should be it. Thank you so much.
Thank you, Xi. And now I'm going to pass it over to Wellington with Michael first.
Yep, Michael up
Yeah.
first. He's just sharing screen at the moment.
Yeah.
So I saw a really good presentation, which seemed quite interesting, and then I found that everything that's required to do what was in the presentation was publicly available or open source. So what I've got here is I've got my PC, which I've built up with a graphics card that's got a good GPU in it, and then on that we're running Stable Diffusion, which looks like that. Not very exciting, lots of words. And then on top of that, it's got automatic UI, which gives me this interface to Stable Diffusion, and you can type a prompt in here and click generate, and then it will down here generate the image you ask for. So I could go say modern house, which was the first part of the Verus example, and it will generate it down there. There we go. You can adjust the batch size and things. And then there's a plugin which is called ControlNet, and ControlNet's quite good because it lets you give an image as guidance for what's generated. So it will actually follow that whatever the image is, it will follow it, which is fundamentally what we saw before. If you put in an image of a house, a screenshot from Revit, for example, and then put the description on it, it will come out with something very similar to the Verus thing. That's not the exciting bit. Then we run this one, which is a plugin that goes on top of all of that, and that gives me this window, which is very exciting. And I'm using a little touch screen and a rather dinky pen, but it's got a screen thing on it, but just so I can draw. So Anton will hold the microphone and I will draw. And then we can edit the prompt. So if we go, you know, let's do some more clouds in the sky. Maybe it's already got the big tree there, but let's make it so the path goes away from it or something like that. And, so fundamentally this works, and then we can change the prompt. So can you break that one up? So we can change that to maybe later. I'm skipping out a few bits. Spring. Wild grass. And then it should regenerate that. And I can just keep editing that, and I can go clear that out again, do a different shape. So maybe we wanted one that was more of a pointy roof because it's a cabin in the woods. Excuse my drawing. I'm drawing on a very small screen with a very fat pen. Let's make it more. Maybe. Did like that river. That was pretty cool. Keep that. We can keep it by adding it to the prompt. River. There we go. So that was what I was going to demonstrate. What I can do as well, this is still being run. Oh, that screen is so slow. This is still being run off the script, off this tool here. And now what I've got is different models loaded. So at the moment I've got an architectural model loaded. It's leaving a lot of artifacts. But I can change it. So I can go, for example, I've downloaded an interior model. I've got one which is called I Can't Believe It's Not a Photo. Let's try the landscape one because it tends to do the trees and things more interesting. So that'll load the model. And then we just need to add something to it to get it to trigger it to run again. Come on, run. Oh, let's add. Oh, that's terrible. And then it should use the other model to generate. There we go. But the thing is, you can just keep sketching. So the landscape one, it does better trees and it does a better landscape. But we can go down here and I've got some other models loaded. For example, there is one that's called Vivid Watercolors. So we'll load that one. I've got to wait till it loads before I draw, otherwise it doesn't. There is a shortcut key to make it run, but I can't remember that. I set this all up 2 weeks ago and then had to turn it off and leave it while I went overseas and then got back today. So there we go, Vivid Watercolor. So you get the different styles. That was what I wanted to demonstrate.
Thank you, Michael.
Later those in Wellington can play.
And up next we have Chris.
Excellent, thank you. Yeah, I just need to get access to the laptop, which is coming. All right. Oh, hello, folks. So this is machine learning through a materialist lens. I'm Chris. I work for Aurecon as a consultant in design automation. In terms of what we're covering, if I can, this one here, there we go, beautiful. In terms of what we're covering, basically, I was just interested in what this machine learning industry is. An important caveat is that this doesn't apply to Michael's presentation because it was all done on a laptop. So when we talk about AI, it's like this is big AI. So we're going to talk about the industry structure really quick, the corpus where the data comes from, the workforce that works with the corpus, the server infrastructure that stores it, and the workflows that sort of generate it. Yeah, we'll see if we can get through that in 5 to 6 minutes. All my references can be made available if folks are interested. So when we talk about the structure of AI, generally we interact with AI vendors like Midjourney, like ChatGPT, now Microsoft at that one layer. So I'm not particularly interested in that. I want to know sort of how they are interacting and getting the data that they need access to. So say that Midjourney, historically had issues with human hands. So how would they go about improving their hands? What they're going to do is they're going to go to a data vendor and they're going to say, hey, our engineers have decided that in order for hands to be improved, they're going to need these, these 120,000 pictures of hands recategorized with these additional 5 or 6 parameters and these areas locked in. Do you have additional hand data that we can use? And do you have a workforce that can go through that annotation process? The data vendors will say, yep, we'll take your data, which you've pulled from somewhere. We can add these additional data sets to it for a fee. And we have access to the outsourcing companies that are going to go and get all that work annotated for you. Then that work is going to be annotated. It will be fed up to the vendors who will then say, hey, that worked or didn't work, or these need to be changed, or these data sets didn't work, these additional fields need to be filled in order for our model to perform. And that goes in a very human-centric and iterative way until you get a model given to you as a customer that looks like magic. So when we talk about the corpus, everyone sort of knows about this, so I can skip over it fairly quick. Generally, when we're talking about these big businesses, like straight from the internet, there's a forgiveness not permission model that's sort of been had. So there's lots of pirated media, copyrighted works, things like that. There are legal data sets like this person does not exist, for example. There's a question about legality where that goes, well, did you ask the individuals in the photos, or did you ask the photographers, et cetera, et cetera? And in terms of other places the data could come from, it could be purchased or it could be resold. So they could have, for example, all of the data in Reddit has been purchased and then resold multiple times and recategorized by different companies over the years. Now, when we talk about the workforce, I think this is where it gets really interesting because I don't think people realize this. So Google has sort of, it's quite secretive, but Google released some documentation saying it's more than millions, but less than a billion. So that lower band of millions is the gig workers and full-time workers. So that's people on $1 an hour for, hands, feet. I don't know why I'm focusing on hands and feet. Anything, costumes. Fish, whatever, all the way up to if it's like lawyers who need to look over legal documentation and mark that up for specific information, that's about $50 an hour, and that'll be US based. When we say that 1 billion number, that's probably the work that you are doing for free through your captures, through various other, various things that pop up on your phone and A/B testing that's happening in ads that you don't realize is happening. And the other thing to realize is that when we say like, hey, mark up hands or mark up costumes, that is like a hyper-targeted and specific request that is farmed out to work centers that then do that work. So if in the specific example, 45 pages of guidance on exactly how to label clothing, do this, don't do this, this is a helmet, this is a hat, this is not a helmet, blah, blah, blah. Read all of that. Workers are then required to do a quiz demonstrating that they understand those rules. So people who would not, be able to fulfill that are filtered out, and then they would do 8 hours of that kind of work, going through hundreds of photos in a day and doing very, very, very tedious markup. When it comes to video annotation, that could be like, it takes you 8 hours will take you a couple of seconds. Sorry, a couple of seconds will take you 8 hours. So very, very, very human and very, very manual process. And the other key takeaway is this is what works, because if they could do it unsupervised and purely machine learning driven, they would have cut out all these middlemen by now. When we talk about server infrastructure, so it's about Google's energy bill for AI is about 5% of NZ's energy generation. The reason we've seen such a pivot from crypto into AI is because it uses the same infrastructure. So graphics cards churning 24/7 in data warehouses. So from what I have seen, and this might be wrong, and I am not a scientist, I am a weird nerd. ChatGPT about 3 watt-hours per query. 3 to 5 queries is 1 LED light bulb on for an hour? Question mark. sitting next to a lighting guy. The danger here, of course, is not about those like small individual use cases. It's about the induced demand and also the abstraction. So if you receive a query that is then filtered through, has 20 queries of pre-training before it gets to you, and then has 20 more queries post-processing after you receive it, it's going to get exponentially worse, and it's going to do that quickly. And in most cases, all of this data is being sent to and stored in the USA, so their data privacy laws and also their energy generation rules. So you're not quite sure about where this is going or if it's renewable. And I think this is the important takeaway for this group here is when we say it's learning, what do we do? What are we saying? If you are, unless you have explicitly ticked a box saying, I decline to have my information shared, you need to assume that anything that you're putting into these apps is going to be sat down and reviewed by engineers in a room. It's going to be sent to people for individual targeted markup. And because that's what is happening in the legal profession, right? Like if legalese gets sent to ChatGPT, it is being reviewed by lawyers for $50 an hour, which will presumably change. The point is that when Microsoft eventually wants to offer a AEC vertical that like produces, for example, digital work plans, it's going to be viewed by industry professionals. It's going to be discussed in rooms. So like you just need to really make sure that you're treating any information that you're putting in there, unless you have a clear relationship with the vendor and a clear like signed contract or whatever, as a disclosure to a person who will be reviewing the work that you put in. So I guess in terms of takeaways, I think it's really important to look at the edifit, like the whole thing, and sort of situate yourself in it, because it's very easy to think I'm doing AI, but you're not, because AI is human reinforcement learning. It requires huge amounts of human capital and engineering iteration. So it's really important to situate as yourself as an AI vendor customer. So if you think you've discovered a clever use for AI, it's sort of like, hey, I'm selling something really good on Amazon, in the sense that Amazon is looking at what you're doing, seeing what works, and it will compete with you. So you can expect, like something like that to sort of come in the near future. The other thing is this still could be a bubble. That's not. I'm not going to try and predict anything, but it could be. ChatGPT use dropped about 10 to 20% this month because none of the students need to cheat on their exams anymore. They all went home. But the thing is that dip, none of those people were potential customers. So there's induced demand because it's free. And we're in a situation of rising interest rates. None of that labor, the annotation labor, is particularly cheap. We know that unsupervised training has mixed results or doesn't work at all, because if unsupervised training worked, they wouldn't need that huge workforce. And the other thing is like the reason I'm sort of laying this all out is because this, I think, is the reality of this becoming scaled and productized. These are the moves being made in the industries that have been put together over the last 10 years. And it's just important to like consider yourself in that context of that industry at scale. None of this negates how cool generative design is. My entire career is built on generative design and believing in generative design. I believe that remote scaled compute is going to be incredibly important to all of us in the future. But I think it's just important to have this sort of mindset when you're going into future, engagements with this. And yeah, that's it. Thank you. Thank you very much.
All right, back over to you in Auckland.
Amazing. Thanks, Chris. Boris?
So that was a really good presentation, really interesting to see what's going on under the hood. I hope my presentation will be as interesting. Oh, first of all, I'm Boris. I'm the data lead at Holmes next door. Last year, my boss told me, hey, Boris, we have about 70 terabytes of project information in various folders. Why don't you use artificial intelligence to surface something smart about this data? I was like, yeah, oh, yeah, sure. I'll give it a try. So I kind of dabbled with it, but I didn't get to any like super good outcome because yeah, the requirement was quite generic. And then a couple of months ago, I was talking to an engineer in the US in our San Francisco office who's working on fire protection. So basically, they offer fire protection to some buildings, and those fire protection needs to respect civil code, which is responsibility of the local council. And sometimes the solution that they have doesn't match by the letter, the code, but it matches the spirit. In this case, we need to submit an alternate code request to the council saying, hey, we cannot do exactly what you want, but this is what we are proposing, and this is why it's going to work. And then the council will say yes or nay, you can use that. But basically what happens is when they are in this case, they need to actually submit this alternate code request. Sometimes I wonder, oh, have we done this before? So what they would do traditionally, they would go see the old guy in the corner, say, hey, have you been in this situation before? Have you seen this use case? And then the guy would say, oh, yeah, I remember a couple of years ago, we used those fire curtains that we submitted to the council, and we could use them. Let me dig in my documents, and then they will. So it's pretty manual. So the idea here is to actually use those documents. So it's like a smaller data set, you know, I can just focus on the ones that are related to those fire protection and so related to those alternate code requests. And given a set of keywords, like, you know, the specific council, the specific type of problems, then I can surface the documents that are relevant to my current problem and find maybe something that was similar enough that I can reuse. So that was a more specific outcome with more manageable data set. So I got onto it. And initially, my idea was to use Azure search service. I'm not sure if you're familiar with it, but basically, if you look at the screen and remove the custom skills that's in the middle, so ignore that for now, out of the box, it's very easy to set up this search service. The input will be blob storage, so some file in blob storage. Those files will be read by the search service, and they will be enriched with metadata, which will become an index. So out of the box, your index contains very basic metadata. It will include the dates, creation dates, who is the author of the document, your title, the size of the document. So while it helps search for documents, it's not super smart. It's pretty basic. But what Microsoft have been introducing is the fact that you can enrich, you can add to this pipeline by using a AI skill, which basically is like your indexer on steroid. So it will add some smart to your indexer to surface more metadata, more structured metadata to have like a richer index with more relevant information. So I'm going to zoom in into those custom skills. So standard use for it, 4 minutes, is like an invoice. It's a very structured document. So basically in your invoice, you can select those different areas of your invoice and identify what it is, you know, like the amount due, the billing address. So basically you're trained your form recognizer, which is the name of the skill, to read an invoice and transform a PDF into a structured document. And then you can just throw any invoice at it and it will return very structured data. Okay, that's great. It didn't quite work for me because that's my type of document I was using. And also, depending on the council, the format of the document will be different. So instead, I use like the generic document recognizer, which basically you cannot train it because your documents will look different. So you just let it go with it. We still have some interesting outcomes. So for example, it could identify, you know, phone, fax, the name. In the middle left, I have the code section, which can be interesting as a keyword when I'm searching, when I'm trying to resolve a problem that may be related to a specific section of the code. If I could enter that as a keyword, it could surface also document that relate to this code section. So there are some potential. However, you can see on the right-hand side the key value pairs that are extracted from this document. Some of them are a little bit weird. So it will require some more work to refine the outcome. But basically, the idea stays the same. Basically, I want to enrich my index with more smarter metadata, so then I can search my index with the code or name or council or city and get those documents that I'm interested in. So that was my first approach, which is still in progress. And then we started to use a different avenue as well. We started to play with OpenAI, which is powering ChatGPT. So our first proof of concept was just using a handful of documents and use Python and OpenAI API to answer simple questions about our handful of documents. So very simple proof of concept that which led to interesting results. Which made us pursue more and go through and start working on a second proof of concept, this time using the implementation of OpenAI in Azure, because Azure is our platform, and also using a more substantial set of documents, because what we want to validate is actually that the outcome we are getting from this OpenAI chat style prompt, we want to make sure that it can provide the right answer for our questions. It's still work in progress. We are finding that it's more difficult than what it's advertised by Microsoft when they do a presentation. They make it look like, yeah, that's easy. And out of the box, you will be able to do a lot. Actually, it requires a lot of configuration and work to make it work, to make it relevant. But again, we see some positive results out of it. And I think, at the end of the day, we'll probably use a combination of those different technology, because the initial technology where you have a very structured index with metadata, it's good, but you cannot use like natural language to ask question. You have to know exactly what keywords you are looking for, and you cannot query data that you haven't indexed really. Whereas if you use OpenAI and ChatGPT, you're querying your entire content, but it's not as directed as structured as using an index. But by combining both technology, we are hoping to be able to have like really good results and be able to find those documents that will help us drive our action, our decision to create those new cold datanet requests. And that's me.
Thank you so much. And then we have the last presenter, Asem. Anybody knows how to start a presentation? Make it full screen. I mean, that's okay like that.
Okay.
All right. Kia ora tātou. My name is Asem Zabin. I'm going to talk to you about just a few applications of machine learning to BIM. I thought I'm going to be the first presenter actually, but that's all right. We've seen some really good stuff, and I think it actually works really nicely now because we've seen some really good presentations. So thanks everyone before me who presented. In 2014, I did a machine learning application on BIM. It was about capturing information of materials. So you know how we are very familiar now with LiDAR and how we can go and capture a lot of good geometry. one of the topics I was bothering me is how do you capture material? Like we get some really good models in terms of geometry, but we don't have anything to do when it comes to material. So we did a really good research. And back in 2014, we trained a lot of gypsum material and lots of concrete material. We put it in Python. We did some magic there. And every time you go and scan it, it detects what kind of material. So we can get the texture and the material, and we can know if it's good and not good. That was back in 2014. I moved to New Zealand in 2018. I worked on the City Rail Link project, and now I'm working in GHT. And I'm also a part-time PhD student. The first thing I did in my PhD is I went and I looked at some of the applications of machine learning to BIM. And the topic that I really want to understand was, my focus is a bit different this time, is I was very interested in all the information, all the knowledge that we have in the BIM models. So this screen here shows you that we get a lot of data sources, and I'm going to go and explore them a little bit further. We put them in our BIM models, we get them from different sources, and then we extract a lot of information. So our BIM models, as we know, are very, very information rich. And what I really wanted to focus on in this research is what can we do in terms of machine learning to extract the knowledge. I'm very passionate about the human information interaction, and this is really what I wanted to focus on this paper. So I said, let me start by understanding all the machine learning applications in the last decade. So we went and we explored 195 papers to get to this, to understand this. So I'm going to walk you quickly through this because I've got 5 minutes only. So we looked at design, construction, and operation. And the design, the data sources that we found, they come from semantic BIM data. We've got design documents. We've got construction BIM models as well, because you learn from them as well. You've got as-built BIM models and some historical materials, cost, and waste. All of this go into a BIM model, and then once you extract them, as you know, this is the beauty of it. You get different stuff. So you get TXT files, SQL, you got Excel sheets, CSV, images, you name it. And we've seen some of these things today in our presentation. And then what we saw, some of the applications are, they can help you with automation, as we know, clearly. Classification, so clash detection was one of the top stuff in the design, as you can expect. Productivity analysis, this is a really interesting one. I'm going to highlight this very quickly. What they did in this research is they actually went to the log files of Revit, and they've did some data mining on these log files to understand what were the most commands used, what were the most, how much time was spent on using these commands. And I think from memory, it was delete was the most common use, and duplicate. So it was very interesting. Automate rules checking, a lot of stuff about energy, and some really interesting research. Only 2 papers about waste analysis. Now, when it comes to construction, same stuff. So the data sources do change a little bit. We do have some IoT sensors, as you can see there. So this also was very interesting to see. And of course, construction schedules start coming into the game. Again, when you extract data, so Excel, IFC, images, Revit, one could argue a lot of these things are actually the same thing. But this is really what we are trying to highlight. Again, what these people in construction are interested in is automation, but for them is automating the construction schedule, improve the construction monitoring. So a lot of these, you've seen probably like images taken on the construction site, and how do they highlight them? They bring them back to the BIM model, and they do some machine learning magic. There's a lot of machine learning applications there. I don't have time to explain it today. Again, cost estimation was one of the stuff, and risk identification is very important, as you know. If you work in construction industry, these are the things you really, really care about. And then operations and maintenance, same story. So you've got semantic BIM, you've got facility management documents, you've got construction BIM models, and some geospatial systems. Again, IoT does come to play here. Really interesting stuff here is, of course, intelligent knowledge-based BIM systems. Indoor localization was one of the things. So this is how do you localize within a system like a building like this one? How do you understand where things are? How do you automate this? Again, maintenance prediction models, again, based on the BIM models you have, based on all the information you put in the BIM models. There's a lot of different ideas about how you automate, how you do this more efficiently and better. Finish that chapter, and I'm like, all right, now I know what I need to do. My next, sorry, before I jump to the next stuff, it wasn't all good stuff. There's few challenges that I found. There's few limitations. A classic limitation here is, I would say 90% of these researches were done on buildings. There's very, very few researches about the infrastructure, whether it's water, whether it's transport, very few. We barely found few things. A very classic, another one is data. As you know very well, that's why you're here in this room today. Good data gives you good results. So if you want to do a good machine learning, good AI, good data does give you a lot of good stuff. And the third, but not the last one, is the size of these projects. All of these projects were more or less pilot or really small scale. And so we questioned is how scalable are they? How can you actually take them and apply them and scale them into like real projects and bigger projects? And that was really very limited in what we found. What I'm gonna do next in my research life, my other part of my life, apart from my work and my karaoke skills, is I'm gonna go and try to extract information from these BIM models with natural language, right? So I've got a way more detailed framework, but I brought the very first one that I created today just for simplicity. But basically, it's the same story. We've got really good BIM models, lots of knowledge in these BIM models. And all I want to do really is for people not to learn the software. I want the operations and maintenance people to come to the room and talk to the BIM model and ask two questions. What is the problem today? And what do I need to do? In a very natural language, and that system, your digital twin ideally, should be able to tell you what is the problem, or what do I need to worry about today, and how do I do it, or something like this, or this. The biggest challenge will be here is not the AI, it's not the GPT stuff, it's the domain knowledge. And this here is what we call ontology. This is gonna be my next focus, creating those ontologies. And this is something I would recommend all of you to go and look for it, ontologies, which is really concepts, instances, and frameworks that all link your information together that the machine can understand, is our biggest contribution probably in the civil engineering or in this AEC industry. And then the rest, in my opinion, is not a big deal because obviously we have ChatGPT nowadays. We have a lot of really good stuff from Microsoft, Amazon, etc. That's me. Thank you so much.
Thank you. Can I ask all of the presenters maybe to come here for the questions? And I was just going to bring up the names of the presenters again, just in case you don't remember who presented what, for asking the questions. And before the question, can I just have a last round of applause for these people? That, like, thank you. Also in Wellington, particularly Michael, that ran from the airport to the Mahoney office to present tonight. Thanks. Right, so questions. Has anybody got any questions? And Anthony, if you don't mind, maybe I'll start with Auckland, and then I'll just go around with the mic.
Cheers. Yeah, really nice presentation. I just had a general question, and I know it's sort of early days, but just thought I'd ask, and if anyone's got experience in the panel, it's just around like, what's the sensitivity of the quality of outputs of these models relative to the size of the training data set, given that the main value proposition is in, the different companies using models that are trained on proprietary data. So would the, say, terabytes of proprietary data have a noticeable or meaningful effect on the output, given the models themselves are being trained on petabytes of data?
Who wants to answer that? Is there anyone in Wellington who wants to answer that?
I can tell you what I've got. My base models are in the order of 4 to 5 terabytes, but there's LoRa models, which is a type of model which focuses on a particular point of the generation and influences it at that point. So the vivid watercolor is one of those. and they're quite small. They're less than a gigabyte. Did I say terabytes or gigabytes? Gigabytes. Mine are 4 to 5 gigabytes. My models that we use to generate those images, and the LoRa ones are less than a gigabyte. Sorry, I've been traveling for too long. And there's another type whose name I can't remember off my head, but they're basically prompt improvers. So they are only less than megabytes. They can be kilobytes. And you type in your prompt, and then basically internally it transforms that prompt into what you really meant, and then generates the image from that.
And just to add to that, there's also I guess a general thing about these huge models. They're designed for like a large market. One of the interesting things is that you can actually train a very small model on those large models and get the benefit of the training. So what we might see is, yeah, these things start to fragment and get smaller rather than more generalized. Because yeah, when it comes to architectural visualization, we just need something that visualizes architecture, and you don't want random, ghosts of, I don't know, thinking a tree is the grimace or something, like coming into it. You don't even want to know, like in a perfect world, your ChatGPT wouldn't know about Hitler. You rather than having to spend a huge amount of time making sure you remove all of those potential references from the database.
From my point of view, even though a few terabytes may be pales in comparison of the petabytes that you can find out there on the web, but it's enough data to have a good outcome. But we shouldn't have the illusion that it's easy. The things that maybe a lot of people think are just throw artificial intelligence at stuff and it will give you a good outcome. Basically, there is a lot of work in feature engineering, data cleaning, and configuration. So I think there is enough data in our industry to provide good outcomes, but it's not going to come easy. There are a lot of work to surface them and make it happen.
Thank you. Any other questions?
Suppose it's to the whole panel. Okay. The question to the whole panel is, what should people be doing now with projects and designs and 3D models and 2D models to make it easier to make personalized or company models, either for queries or for the future, or just what should people does the panel think people should be doing now to future-proof for AI applications?
Signing contracts, like finding a vendor, negotiating an enterprise contract, and making sure it's watertight. It's very boring, but I think it's, depending on the size of your firm or your organization, you want to be making sure that your data is, secure. I don't think you're going to fall behind. The stuff is just going to get easier to work with in the sense that it is becoming more productized.
What's been a problem at Holmes, it's a spiky problem, is like there is like a lot of automation going on. A lot of engineers try to automate some process. It's great, but they have an application-centric mindset. Like, oh yeah, I'm going to write some code that solves my problem, but really rarely thinks about the data model behind it, which means that the data that they are using is not really reusable. So it's really having like a data-centric approach. Like when you're working on automating something, like what kind of data am I going to use, and try to structure this data and make sense of this data. Because yeah, if you can surface, metadata and structure around this data, that's really going to give a boost to any machine learning or artificial intelligence, because you provide some semantic information straight from the get-go. So having clean and structured data from the beginning as soon as possible is definitely going to make a big difference.
Wait, sorry. I have a second answer, which is remote compute. So making sure that you have good infrastructure internally to run these things, not on desktops. So again, that depending on your scale, that's the other thing to focus on, because an AI query or moment is just part of a chain of getting something up to bin 360, triggering a post-processing exercise, triggering ChatGPT, triggering a database access. So having good controlled remote compute is going to be really important to actually make it scalable.
Some current themes: clear data, clear prompt. So the results are only as good as the data that's provided to the AI platforms. Sounds the current theme. Any other questions? Not in Auckland. Any other questions in Wellington?
No one's putting up their hand here for questions.
Oh, sorry. Yeah. So there was a question here for Michael Warwick, the one in Wellington. How can we put our hands on the live sketch tool that you were using? Is it something that you developed, like in-house?
Give me a second and then I'll give an answer to that.
While you think about that, I would love to try that with one of my daughter's sketches. What are you thinking about?
He's currently getting stuff up on the web.
It's been 2 weeks since I installed it. I couldn't remember the name of it, so I've got it
okay.
now. And I'll share screen for a second. If I can find the it's in that one, isn't it? That one. That button. This is GitHub, House of Secrets SD Paint.
We can't see your screen yet.
Here we go. House of Secrets SD Paint on GitHub. And that's the controls which I should have printed out. But you know. And it's got the installation instructions, which actually tells you what you need to have installed first, which you work backwards through basically. Windows step-by-step instructions. So it's got like you install Stable Diffusion and then the web GUI, and then you install ControlNet and then you run it. But as well on this, it's got no, it doesn't have it. There is a good video about this on YouTube if you search it.
I'm pretty sure that you would have needed a subscription service running that thing, the engine behind it all. Is that true? That it is your demonstration assumes that the user has a subscription to something that runs it all behind the scenes? No,
what I ran was entirely on my box. The only internet needed was so that you could see it in Auckland. Okay. The models, Stable Diffusion is the engine that does the processing. All of that is installed on the one machine. There are no images coming from the internet. There's nothing external. It's entirely running on my machine right now.
Okay, so that's astonishing. So you do need a good graphics card to run that?
Yes.
Okay. There's always a catch.
Yeah. I looked at like what would be the ideal graphics card, and then I saw the price of that, and then I worked my way back until I found one that I could get secondhand off Trade Me at a reasonable price. So yeah, but you could see it was quite fast doing the images. Like you can keep playing with those. you kind of get into an interaction backwards and forwards with the image that you're generating, and you start looking at it and going, oh, let's put some trees there. Those are good. I'll put them into the sketch so that they stay there. Or like it added the river in front, and then the next generation it took that away. So then I added it back in again. But yeah, everything is running on my machine. So there's no subscription service. This is all public domain, and people are building those simpler models in an open source way as well. The LoRa and the Tensor, that's what they're called. The Tensor models and the LoRa models are being built open source, and some of those, like the some of the architectural ones, to train them in a particular architectural style only takes like 100 or so images properly tagged, but then each image has to be trained, so then you've got to run it on a very high end. So somebody else has got to do that to build up the model, but that needs to run on a very, very high end graphics card because it uses a lot of GPU time.
So clear and structured data, clear prompts, and a good graphic card. Right, any more questions? Otherwise, I think we can just finish up here because it's already 7:13. Happy for everyone to just stay here for it to be more, if there's anything else to drink, have another drink, chat, meet people, and hopefully we'll see you all at the next digital user group in a couple of months. Thanks, Wellington, as well.
Thank you, everyone.
Thank you so much.